Hello everyone, how's everybody doing? Hope you're doing fine. And this is Rational Science directly from Frankfurt, Germany. Okay, we're a few hours ahead of US where we have most of the people watching. Uh, so we're in the first world, you're in the second world. Okay, today we're going to be dealing with a very complex figure, probably the most complex figure you can imagine. The square. Before we can get to the square, let me tie a couple of loose ends on extinction. We had that subject the other day, and just for those who are not familiar with this site, let me just briefly say that I have a theory of extinction, mass extinction. It says that all mass extinctions happen because food ran out. Okay? After millions of years, the plants, their population pyramid overturned, okay? And those who get stuck at the end of that process suffer what is known as a mass extinction, all those animals that are caught in that situation. By that time, all these animals have grown in size and in numbers. Just when the plants are coming down, these guys are going up. And where they meet, that's known as a mass extinction. And it happens on land, sea, and air, and it is discriminatory. In other words, it is selective. One food pyramid dies, the other one continues, as if nothing. Okay, so that's the argument, and I'm saying that's going to happen to man as well. Man cannot avoid it. No matter how intelligent he is, no matter what technology he invents, it doesn't matter. Man cannot avoid that same process. And in our case, we make our own food. We, unlike the animals that go out and hunt or eat whatever they find out there, we used to be like that a few thousand years ago. Now we produce our food. But that doesn't change anything, absolutely anything. Because right now we produce food because we created a system called money, okay? Without going into too much detail, it's called money. We produce and distribute thanks to money. If money disappears, no one produces or distributes food, billions of people die in a matter of weeks, okay? And why will money disappear? Well, because our economic system cannot grow forever. That, in a nutshell, is the theory. There's more details you can find in some of the other videos, and I try to to put in some details here and there whenever the time allows, whenever the questions come up, you know, and so I try to explain in more detail as time goes by. Right now, I just want people to understand the overall theory. Money disappears when it does, not if, but when it does. What happens next? What disappears is food, and when food disappears, humans disappear. And it turns out that's the same thing that killed all animals in the past. They died when food disappeared. Not because an asteroid struck, not because a volcano struck, not because there was a supernova, like all these bean brains, so-called scientists, paleontologists say. No, they never discovered that. It's a natural process. Human extinction was programmed by Mother Nature when she spawned us. Okay, and I had a couple questions on that, a couple statements. And, you know, I don't really like to answer questions unless people address what I call Extinction 101, which is mass extinction, before they tackle human extinction. Everybody's an expert in human extinction. We all know how man is not going to die. That's essentially the argument all these people make. And no one can tell me not only how man is going to die in a foolproof way, but, you know, it'd be nice if you start at mass extinction. Tell me how a mass extinction occurs, okay? If you can't tell me that, you know, you shouldn't even bother about man, okay? Because you don't know anything about extinction. And the issue is extinction. It's not economics, it's not politics, it's extinction, and economics plays a role in that because all animals manage one and one only, I guess, the main one, the main resource, which is food. Okay, okay, so one fellow says, I like this one, says, there may be a mass extinction, but I think it will be man-made. Uh-huh. Okay, you think the population is much too big and will eventually destroy the world like a virus. You have the vaccine, though. You can stop growing food on your land or use engineered seeds, which in a few years will stop to grow. Okay, that can kill most of the people on the planet, but not all of them. Well, what this gentleman is missing, among other things, so many errors here, but what he's missing is that, some people will survive the mass extinction that's approaching, okay? Some people always survive at the end of the line. Oh, the problem is they will not reproduce, okay? They will not reproduce, they will not restart the human race like Adam and Eve because our genetic diversity has disappeared. We have no genetic diversity today, okay? So even if they do have kids, we're assuming, I don't think they would, but assuming they would be brave enough to have some kids, 2 or 3 generations later, they're all gone. Okay, all you'll have is autists and kids with 6 fingers and so on. There's no future after that. Okay, so it is, for all practical purposes, the end of man, even though, if you survive, pockets here and there. Okay. Okay, another fella, again, they get into politics. This is not about politics, this is about extinction. Says China respects money. The West is mired in a major Marxist collapse, and Marxists hate capital. China is more capitalistic than the West and is Marxist in name only. What are you going to answer? I mean, poor guy. He's stuck in this world of politics, and that's all he likes to talk about, I guess. Lots of people politics is #1 topic out there. People like to talk about politics. Women probably talk about cosmetics and how you look, and men talk about politics. Nothing has changed in the last 5,000 years. How many people talk about science? How many people talk about a mass extinction and understand it and research it and dig deep in the literature to figure out, what could have happened to those animals? You can count them with the fingers of one hand. Okay. Okay. Another fella says here, the only one who addressed the Extinction 101 to some degree, he says 65 million years ago, the major continents were separated. There were no land bridges between the northern and southern hemispheres. If supervolcanoes shroud the sun for 1+ years, in whichever hemisphere they occur, they cause mass starvation. Given there was no land bridge 65 million years ago, this was not possible. So successive supervolcanoes might extinguish all large land-based creatures across both hemispheres. Yeah, all these people think in catastrophes, and that's why they never get it right. They think something happened now, it was abrupt. The volcanoes cannot explain what happened to the mosasaurs. These were reptiles that lived in the seas, okay? And to what they ate, which were the ammonites, which also disappeared, and they disappeared and they ate something else that disappeared, which were the foraminifera, the plankton out there, diatoms and foraminifera. All these tiny animals, they're the bottom of the food chain. That's what disappeared. So you got to explain how the volcano affected the plankton. That's what you got to explain. Yeah, it's easy to say, yeah, volcano killed the dinosaur. Yeah, great. And this is what you got to explain, really. Here's the graph, okay? Anyone who can explain that gets a beer from me, okay? If you can figure it out, okay? Here it is. This is the Cretaceous Terrestrial Revolution. Took 4 years to build that graph. They studied it for a long time. They collected as much data as they could, and they built this graph. What does this graph show? It shows how plants disappeared. Okay, so what happened around the middle, you could say the middle of that Cretaceous, of that whole period from 145 to 65 million years ago. Well, what happened is that the angiosperms crowded out on the planet all other species. And dinosaurs did not eat angiosperms, even though you'll find a couple papers out there that argue for that. I think these people have no clue. Okay, angiosperms disappeared. Conifers disappeared, and what the angiosperms did, they crowded out especially the gymnosperms. Okay, cycads, ferns, also ferns disappeared as well. The ferns had disappeared when the conifers kicked them out. You know, ferns were the flora of both the Permian and the Triassic. Then what came in were the cycads and the cycad-likes, you know, the Williamsonias and so on, and they kicked out the ferns, and what took over the land were the, were these new types of plants, which were a type of conifer. And then eventually those conifers disappeared because they were pushed out by the angiosperms. And if you look around today, you won't find too many ferns and you won't find too many conifers of any kind. What you will find is angiosperms, flowering plants. That's what mammals eat. Mammals don't eat ferns. Mammals don't eat conifers in general. Maybe you'll find some exception here and there. Some animal that got used to it. In general, mammals don't eat that kind of stuff. And so it's very simple. You know, the Permian and the Triassic were the years of the seed ferns, especially, the ferns in general, but seed ferns especially. Then the Jurassic and Cretaceous were the era of the conifers. And today we have the era of the angiosperms, of the flowering plants. So how did animals die? Well, apparently their food sources disappeared. Very simple. Okay, except for a paleontologist. Paleontologists think that their job is to go out there and find bones, dust them up a little bit, give them a fancy name, set them up in a museum and charge entrance fees. That's what they think a paleontologist is. No, that's a stamp collector. Okay, that's what it's called. Paleontologist is a necrologist. He's a medical examiner. He's a detective. He has to tell me how the crime was committed. That's where he has to break his brain. But, you know, to collect evidence and just bring it in and say, well, I collected all these bones for the court. Well, that's not a paleontologist. No, you have to explain to the jury what you got out of that, what conclusions you came out with. And that's the problem we've had in the last 200 years since paleontology's been around. Not one paleontologist can explain to you a mass extinction. Not one paleontologist can explain to you how a background extinction occurs when a single species disappears. And of course, all the recent one for the last maybe 2,000, 10,000 years, or even more, they say it's man. Man killed them all. We're such mean creatures. We make all these species disappear. We killed the dodo, we killed the passenger pigeon, we killed the great auk, and so on. We killed all these, the Tasmanian tiger. We killed them all. We're such murderers. Yeah. How come we ended up with only one Tasmanian devil? Tasmanian tiger, sorry. That's what you got to explain. How that animal whittled down to nothing. We might have killed the last one, yeah. That doesn't mean that's caused the extinction of these animals. Okay, so, and there's one more here. One fellow says, I can get this thing up there. Oh, come on. Give me a second here. There we go. Says extinction theory. Bill, there is a video, blah, blah, blah. It gives the link where it is supporting your proposal. Absolutely not. There is no one that supports my proposal out there. First of all, because no one knows about it. The only way they're going to find out is coming to this channel. But when you look at all these people who talk about the possibility of extinction, you know, Their arguments have nothing to do with mine. Okay, first of all, none of them. And second, none of them are foolproof. Okay, so all these people talk about extinction. They talk about climate change. They talk about, if we don't do this, we'll become extinct. They're just giving you a recommendation. They don't know how man will become extinct no matter what. Guaranteed. No one says that. No one says that it's guaranteed that man will become extinct. And I'm telling you it's guaranteed because the economy will collapse. And when, not if, but when it collapses, no one will produce food. Billions will die. You don't eat, you die. It's very simple. And that's how you can kill 8 billion people. If they don't eat for weeks, it doesn't matter. They're going to die. And so I do have a foolproof mechanism. I say it's guaranteed and it will happen, and it will happen very soon. That's very different than what all these people say. These people have no clue about extinction whatsoever. Most of them talk about climate change and we got to do something about the climate. Climate has nothing at all to do with extinction. The only role of climate change is when the new species of animals radiate. Once the big guys are gone, when the dinosaurs were gone, all these tiny mammals, they could expand. Why? Because the big guys were out of the way. That's one issue. The other one is that their sources of food were expanding as well. The angiosperms were displacing the conifers. That's why they could expand as well. And of course, all these animals, they each one squatted some niche here and there, and they grew into the animals we have today. And we're one of them. Even though some people don't think that humans are animals, they think we're not, because they say they have a brain. And that makes me very suspicious whether they really have a brain or not. I don't know about that. Okay, let's get to the subject matter today, which is the square. Now, we all know what a square is. I mean, do we need to spend a lecture on the square? I mean, the other day we did circles, then we did semicircles, and today we're going to do the squares. Don't you have anything better to talk about, Bill? Well, I would if it were that someone out there can tell me what a square is, but it turns out no one knows what a square is, just like no one knows what a circle is, okay? That's going to be my argument today. If you know what a square is, please show me, okay? I'm going to show you today that no one in geometry, especially those who teach geometry, no one has any idea what a circle is. No one knows or understands what a semicircle is. And no one, absolutely no one has any idea what a square is. After 3,000 years, that they cannot tell you what a square is. In fact, you'll find a lot of these so-called geometers, and the first thing they'll say is, oh, we don't know what a point is because it's an undefined figure, I guess, whatever they call it, and it's an undefined term, and the line is undefined. And so they have all these undefined terms, and it turns out those terms form the foundations of geometry. It's got to give you a clue that these fellows, they have no idea whatsoever what any of the higher figures are, like, squares and cubes and so on. I mean, if they don't know what a point is and a point underlies their other figures, what can they tell us about the higher figures? Okay? So that's more or less going to be the argument today, but I will be more specific. Let's get started here. Here we have, is that a square? I mean, if I asked you, please draw a square, or I ask a kindergartner, because you might be biased already, but let's ask a kindergartner, someone in elementary school, a kid that's anywhere from 5 to 10 years old. Okay, draw me a square. What would you draw? Or I show them a square, a circle, and a triangle, for example. And I say, which one is the square? Do you think he would be able to identify the square? I think he would, because he's unbiased. He's been taught, yeah, that's the square, the one over there. And that's what I'm showing there. That's the square, and that's what a lot of people would draw, and that's what a lot of people would point to. Okay, they say, yeah, that's the square. No, that's not the square. So if this is what you think is a square, you never learned geometry. Okay? You have no clue whatsoever about geometry if you think that's a square. Okay? And first thing we have to ask is whether a square is a geometric figure. Okay? And then the question is, well, what is a figure? Because it turns out that we have Wolfram. They say they're the most popular, the most advanced site on the internet regarding mathematics and geometry. And you ask them, well, what is a circle? And they say, what's a figure that blah, 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 blah. And you say, okay, what is a figure? And they don't have a definition for the word figure. So their whole argument falls apart because the key word is missing in their entire website. You don't have a definition for the word figure. Okay? Fortunately, Mr. Euclid did a little better job. He tried to define figure, whether he did it right or not. At least he tried. Okay? So in that sense, I have to give credit to Mr. Euclid. Okay, so why don't we start at the beginning? We're doing physics here. This is what physics is about, what this channel is about. It's about physics. And the question is, does physics require an object? Can you do physics without an object? If you erase all matter in the universe, can you do what's happening? What's going on? What's moving? What are you staring at? What tests are you going to run? What are you going to juggle? What are you going to study if there's nothing there? So I'm saying that the first rule, the first law, the first principle of physics is you cannot do physics without an object. You need an object to do physics. Okay, you can't move concepts around. You can't move love over here and energy over there. You have to use a physical object. So we need to know what an object is, and object is a synonym of that word there, figure. Okay? So here goes. These are the questions for anyone who wants to be a physicist. If you elude these questions, you're just hiding your religion. You have no idea what physics is about. So these are the questions a physicist must answer and cannot avoid. Okay? First one are topics such as what causes gravity, what causes magnetism. Are those a part of physics? Are those questions of physics? Those questions that a physicist must answer. What causes gravity? Here we have a pen, okay? And we let it go, and it falls to the floor, in this case the table, right? It falls always downward, never falls upwards. I don't know why, Do we have to answer those questions? Are those questions of physics? Are those questions that a physicist is interested in answering? That's the first issue. Do we explain mechanisms in physics? Here we have a mechanism, okay? We let go of the pen, it falls. There's some kind of mechanism going on, okay? Something's happening there, okay? And so do we explain mechanisms in physics? Is that part of the subject matter of physics? Yes or no? These are all yes or no questions, by the way, okay? Or are such issues subject matter of philosophy? Is this a question of philosophy of what causes this to fall to the floor? Is this philosophy? I always use my two little magnets there, okay? This is a mechanism. Something's going on here. It's already pulling on my fingers. It's already, you can draw, you can do it at your own leisure at home. Take two magnets, you'll see, one pulls on the other. Is the mechanism, is that an issue of physics, or is this an issue of philosophy or religion or some other? Is this an issue of psychology, consciousness? I don't know. So it's a yes or no question. Is it an issue of philosophy? Can we explain a mechanism without objects? If I don't have an object, can I explain, for example, here, let me give you an example. Okay, here's a ball, and it's tied to a little string, okay, a little elastic string, okay. So I'm doing like that. If I had to explain why the ball goes up and down, could I explain it to you without referring to this elastic band? I mean, can I explain this phenomenon that the ball is bouncing up and down? I'm talking about an explanation, not describing. I don't want to describe, I don't want to know how fast it goes. I want to know why it goes up and down. And everybody would say, well, you're pulling on the string. Okay, that's fine. But could you do it without referencing the string? Could you explain the mechanism of why that ball goes up and down without talking about the string? And that's what I'm saying. Can you explain a mechanism without using an object? In fact, if I got rid of the ball as well, there would be nothing to explain. There would be nothing going up and down. So here are the issues. Those 4 questions, they're yes or no. You can't miss any of them. If you miss answering those in a rational way, you're first an irrational individual, and second, you're hiding something. You're hiding behind you're shielding yourself behind some kind of religion, something you have deep inside you. So this is a good way of psychoanalyzing yourself. You're hiding something. You're not willing to answer those questions because they destroy your religion, destroy your way of thinking, how you grew up, how you were educated. That's why you would try to avoid these questions. That's the only reason you would try to avoid them. Okay? Okay. So you got to answer those questions if you want to be a physicist. Otherwise, you're just going to be doing religion. Okay. Here's for instance, here you see a pulley. Okay, pulling on a box. Okay. There's a rope tied around the pulley, tied to the box, and pulls it up. Okay, we need to explain that. You need to have the rope, you need to have the pulley, and you have to have the box. You have to point to all these objects, okay, these figures, these things, and then you can explain it, how the box goes up. Now, what if I showed this? The box just goes up. And I say, well, where's the box going up? Well, what would you say? There are spirits, magic, black magic. What are you going to introduce here to explain why that box goes up? Okay, that's what you got to explain. You got to explain why that box goes up. You're going to need to put in some physical objects. You're going to have to identify the objects. Okay, otherwise you're doing religion. You're introducing spirits, black magic, God, who knows. Okay, so if we need an object to do physics, what the hell is an object? What is this thing called figure? Okay, see if I can get this thing up there. Give me a second here. Okay, so in physics, we define an object as that which has shape. And what do we mean by that? Well, it means that it's the only universal property of all objects. All objects have shape. There is not a single object that does not have shape. And if you can think of one, please draw it. Okay. So if you know of an object that doesn't have shape, please draw it. Okay. It's got to be standalone. It's got to be independent. What do we mean by that? Well, you should be able to point to it. And it should be the only object in the universe when you present it. Okay, it's like there's nothing else in the universe. We got to have, like in that case, you see an example there. You see that whatchamacallit? And that's an object. Why is it an object? Because it has shape. The black stuff is just space. That's the background that gives contour to the object. If that black background wasn't there, the object would be infinite, and then therefore it wouldn't be an object, because an object is that which has shape. So it has to have some contour. Okay. Now that black stuff does that have shape? And the answer is no. The black stuff is nothing, that which doesn't have shape. So we have shape within that which doesn't have shape, and that which doesn't have shape is put there just so that you can identify the shape. Okay? So that's an object for the purposes of physics. As you can see, it's standing alone. There's no other object nearby. We don't need any other object to call that one X, object called X. Okay? It's an independent object, unlike a magnetic field, which depends on the magnet. Okay? This one doesn't depend on anything. Okay? It stands alone. Okay? So in that sense, it's the sole object in the universe. We should be able to put it out there in the middle of space all by itself. Okay? Or you should be able to point to it. Okay? It's got to be motionless. No object involves motion. And please keep that in mind for what we're going to be talking about today, which is the square. Okay, I'll talk a little bit about the circle as well, but important. Motionless, timeless. What do we mean by that? Well, it occupies a single frame in the universal movie. Okay, if it occupies two frames, it's not an object. It's an object in motion, and an object in motion is not an object. For example, plasma is not an object. It's not a standalone object. Plasma means ionized gas. It's a concept. And wave, the transverse wave, not an object. Okay, wave is something in motion, and so on down the line. So you can't use these words, energy, another one, mass. All those are concepts, dynamic concepts. Not one of them is a standalone object, because you need two frames in the movie to talk about energy, mass, ether, any of these. Okay, you need two frames in the movie. Okay, an object is not a concept. Okay, and a lot of people confuse them. They think objects are concepts. We had one fellow who said that a two-dimensional object is a concept, so we have two-dimensional concepts. Okay, and object and concept are the only two categories of every word in the dictionary. Every word in the dictionary has to fall under concept or object. There is no third category. Okay, and if you have a different category, you need to put that in there and defend it. Not only just put it, but defend it. And I'm going to show you that it's one of the two. If it has shape, it's going to be an object. If it doesn't have shape, it's going to be a concept. There is no third possibility. God either has shape or God doesn't have shape. God cannot be both, have shape and not have shape. Okay, he can't be both an object and a concept simultaneously. So you got to decide who you're praying to, whether the object called God, the guy with a magic wand, I guess, or the concept called love or spirit or knowledge or intelligence or whatever. Okay, and we should not confuse the word object with the word exist, which is where 99% of the problems are out there. People confuse the word object with the word exist. Okay? They think that these two words are synonyms. Okay, and I'll be talking about that a little bit today. What's my conclusion? The definition of the word object destroys all religions. Once you define the word object, no religion can stand in place. Okay? No one can defend their religion once you define the word object. And all they can do is run away with their tails between their legs, not define the word object, saying they will not play that game, etc., etc., etc. That's all they can do. They cannot come in there and define the word object in any other way. And so, that's the trick. You got to define the word object. Don't tell me what an object ain't. Tell me what an object is. Okay? If you can't define the word object, you have no standing, especially in physics. Because physics cannot be done without an object. It's a mandatory word. The first word a physicist must define. Okay? So I hope that's clear. Okay, let's move on here. Oh. Got to get these from all the way from the bottom. Okay. Okay, so is a circle or a square, right? Either one, doesn't matter. A figure, is it an object? Is it a thing? Okay, well, according to the definition of object, it is because it has shape. And so what we have to do is go to beginning. And we go to Euclid from his book Elements. This is how this whole thing started, okay? And what did Euclid do? Well, he had a few definitions, especially in his book 1, where he starts all this stuff. He tries to make sense of geometry. The first thing he defines, or one of the first things he defines, is a boundary. He says a boundary is that which is an extremity of anything. Okay, I guess he's referring to the perimeter, the outside edge, any way you want to describe that. Okay, so I think a boundary, we understand what he's trying to say there, I think. Okay. I don't know if anyone has any objection to his notion, his general notion, what a boundary is. What is a figure? A figure is that which is contained by any boundary or boundaries. Okay, I say it differently. I say it's that which has shape, but it's close enough. I have no objection to Euclid's notion of figure. The only objection I have is that he never used that definition. That's the problem with his definition. Neither him nor anyone who came after ever used that definition. And even worse, they never realized how important that definition was. You can't do physics without an object, meaning can't do physics without a figure. And it turns out that everybody does physics without a figure because they never define what a figure is. They don't know what a figure is, and they never did physics. Okay, that's where the problem is. Okay, so he says, what is a circle? A circle is a plane figure. Blah, 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 blah. Okay, so it's a figure. It's a thing. It's got a boundary. Okay, and he said in definition 14, he says that which is contained by. So he's saying that it's the inside which is a circle. Okay, very important distinction to what we have today. What is a square? Well, of quadrilateral figures. A square is that which is both equilateral and right angled. In other words, it's got four sides. That's what quadrilateral means. And it's got four angles. Okay, four right angles. Okay, so is that what a square is? Okay, or is this a description of a square? I mean, I need to know what a square is before you can describe it. What Euclid did was something totally irrational. He's trying to define an object. You can't define an object. You don't define the word man. You point to a man. You don't define the word table. You point to a table, then you can describe it and say, yeah, it's got four legs, you know, a board. You know, you can go out there and describe it later on. First, you got to point and name it because you need to teach the ET your language. He's got to know what the word table refers to. And you cannot just talk in general terms. Well, it's got four legs and a top and whatever, a board. No, you got to point to it. Then he knows what the word table refers to. Now you can do all the descriptions you want. And what Euclid did here, he did not define. He did not point. He did not draw it. He just tried to define it. And that's a big error. It means the geometers of Greece had no clue whatsoever what geometry was about, because if it is about figures, if it's about shapes, what he said, figure there, okay, contained by a boundary, then all he had to do was draw it, and he was done. He said, this is a circle, and this is a square, okay, and no one has ever done that. That's the interesting part. No one has done that. Okay, so do circles, squares belong to a category of geometric figures known as planes? Well, let's see what Euclid has to say about it. He says in definition 5, a surface is that which has length and breadth only. Well, I don't know if it was Euclid or his translator, but breadth is not a dimension. Breadth is a vector, okay? Breadth has to do with motion, you know, sideways motion. Depth is inward motion, and height is upward motion, okay? And no geometer ever figured that out. Those are vectors. You cannot confuse, you cannot mix the word length with the word breadth, because you're talking about two different things. Now, whether that was Euclid's fault or his translator, I don't know, but someone erred grossly, and this error is repeated generation by generation through generation. Okay, do circles and squares have two dimensions? Well, a surface is that which has length and breadth. The edges of a surface are what? Lines. Very important point today. What are the edges of a surface? They are lines. Okay? And keep that in mind. That's a very important point. Lines. I'm going to focus on lines, lines until it hurts today. Okay, a plane surface is a surface which lies evenly with a straight, what? Lines on itself. So we're going to be talking about lines, okay? And then again, do concepts have dimensions? Again, we have this fellow who says that a two-dimensional object is a concept. So we have two-dimensional concepts today. My dear soul. Okay. Let's continue. Let's roll on here. And what is a circle, square contoured by? Well, I think it's going to be by a line, I think. Okay. A plane surface is a surface which lies evenly with the straight what? Lines on itself. Okay? So Euclid defined this plane, whatever plane it is, as something dealing with lines. Okay? And what is in definition 15? He says a circle is a plane figure contained by one what? Line. Okay? And the question is whether that is a line there that you see there. You know, I put a bunch of dots. Is that a line? Well, let's find out. How about a square? Definition 19 says rectilinear figures are those which are contained by what? Straight lines. Quadrilateral, those contained by 4 lines. Definition 22 of quadrilateral figures, a square is that which is both equilateral and right angled. Okay, so what are we talking about? We're talking about lines. I guess we have to get to the bottom of what a line is. But it turns out that, line is what? Made of points. Okay? Here we see it. See if we can find out what this is about. What is a line? Line is breadthless length, according to Euclid. Okay? The ends of a line are what? Points. And a straight line is a line which lies evenly with the what? Points on itself. And what does the Wikipedia say for line today? And everybody says the same thing, so Wikipedia is good enough for this. Line, the set of what? Points. The set of points. Okay. So what is a line? It's not a solid line. It's a set of points. Often described in terms of what? 2 points. You got that from Euclid. Okay. So what is a line? It's a bunch of points. Whether it's curved or straight, doesn't matter. It's a bunch of points. That's what a line is. Okay, so what is a point? I mean, if a plane is made of lines and a line is made of points, let's get down to the nitty gritty. Let's find out what a point is. Okay, and so here we see it. A point is a primitive notion. What do they mean by that? That they won't be able to define it. Why? Because you don't define figures assuming the point is a figure. And that's what we're going to get to. Is a primitive notion upon which the geometry is built. So geometry is built on this thing and they can't define it because it's primitive. Primitive means they can't define it. Okay? Meaning that a point cannot be defined in terms of previously defined objects. Yeah, what are you going to define a point if it's the building block of all the others? So he says it's the bottom one, so we can't define that one. Yeah, you can't define any geometric figure. Figures we point to. And I'm not sure what you're going to point to in the case of a point. Because Euclid says it's that which has no part, meaning no dimensions, no size, no volume, no nothing. A point is zero, it's nothing. That's what a point is. And that's what these people are dealing with, geometers. Okay, geometric points do not have any what? Length, area, volume, or any other dimensional attribute. So what is a point? What kind of geometric, what figure is a point? And maybe that explains why the famous geometers and mathematicians of Wolfram did not define the word figure, because otherwise you would say, well, hold it, it's contained within a boundary. What is a point contained within if it's got no volume, dimensions, length, diameter, or whatever? Yeah, we have a problem. We got to find out why they have so much trouble with the word point. What's the deal here? Okay, the concept of a point. Oh, so it's a concept. I thought it was an object. I thought it was a figure. I thought it was a geometric figure. But it turns out it's a concept. Okay, so we have another concept that this concept is zero-dimensional. Captures the notion of location. The word point in the religion of geometry means location. That's what it means. It's not a geometric figure. It's a concept that they use the word point because they're going to represent it with a dot. But then they're going to tell you, well, forget about the dot. Don't think about the dot. We're just going to focus on what the dot represents, which is a location where something it supposedly is. Well, if something is supposedly in there, like an elephant, why don't you just put the elephant? Why do you represent the elephant with a dot that is two-dimensional at least, maybe three, and then tell me, oh, forget about the dot, that's not the point. The point is what it represents, which is the location of what? Of the elephant. Why did you put the elephant? And what they do is they put the center of mass of the elephant, perhaps, something like that. And so they say, well, we take this whole elephant, well, we don't care about the elephant, we care about his mass. He weighs 5 tons, and we're going to put 5 tons in there. And that's going to be the point. That's going to be the number. That's going to be the dot. That's going to be the point of geometry. They're not going to tell you where the elephant is. They're going to tell you where the point is, which is what? The center of mass of the elephant. Okay, so this is how it's going to be working out. And yeah, that's what a point looks like according to their definition. Okay, and the question is whether location is a geometric figure. Is location a geometric figure? If it's not, it doesn't belong to geometry. We have to start with a geometric figure if we're going to do geometry. So this is where we have a little bit of a problem. Okay, and so here's the line that people think of. They say, well, it's a continuous line. It's made of a single piece, solid, Not in geometry. Geometry looks more like this. Is that what it is? Well, it turns out it's not even that. Not even that. This is the line of geometry. That one there. Okay? So keep in mind, this is the line of geometry. Let me put it over here. That's what a line is in geometry. A moving point. Which is what? Location. Yeah. The point occupies, the location occupies many locations. What are we talking about? We're talking about motion. Because 2 or more locations is motion. And so this is the problem here. The problem is that these people are talking about geometry, figures, boundaries, and they don't use any of that at all. Not at all. What they want is relations. They want to measure something, and they want to look at angles, and they want to look at speeds and that kind of thing, or ratios, or things of that nature. They're not going to look at the geometry itself. They don't care about objects because no mathematician ever on planet Earth ever cared about objects. That's why they're the wrong people to do physics, because like I said at the beginning, you can't do physics without an object, and the first job of a physicist is to define the word object. That's what we're going to be working with. If you're going to explain a mechanism, like the pulley, or like I said, the ball here that's hanging, right? More or less like a pulley. Then you're going to need objects. You don't need any math at all. You don't need any relations or ratios or anything like that. No, all you need to do is identify the objects and tell me what the mechanism is. That's what we want to do in physics. We want to explain gravity. We want to explain magnetism. We want to explain why light travels so fast. What is light? We want to know what an atom looks like, why it does its quantum jump. Those are the questions. What is electricity? Those are the questions of physics. And those are all mechanisms. You don't need any math for any of them. Math is not the language of physics. Illustration is the language of physics. You have to illustrate. You got to make a movie of your theory. Okay? And so if that's the point, okay, and if that's the line and the line is just a moving point, then what is a line? Well, a line is an itinerary, a trajectory. It's motion. That's what a line is to a geometer. And that's exactly what all these mathematicians put in their equations. They're not talking about a line. They use the word line, you think of, oh yeah, a solid line. Absolutely not. They're talking about an itinerary. That's why they call it one-dimensional. Because what they're talking about is not that it has 3 dimensions. Obviously, if anything that in our macro world that moves is 3-dimensional. And you say, well, how can a line be 1-dimensional? I can't even draw that, because you can't draw anything that's 1-dimensional. As soon as you put that pencil or the chalk, on a surface, you've got 2 dimensions at minimum. So there is no such thing as 1-dimensional. What are they talking about? They're talking about motion. That's why they use the term 1-dimensional, because they're saying it's just a line. They're moving along a line. They're not talking about lines. They're not talking about Objects, what they're talking about is motion, and motion is made of locations, and that's what the point is. So we're not talking about geometry at all. We're talking about locations, and we're talking about motion. Okay? That's what a geometer does. It doesn't deal with geometries at all, with figures at all. Okay, so let's continue here. And so a circle, we start with the circle, right? A circle is a simple closed curve. What is a curve? Well, a curve is made of points. It's a line, and a line is made of points. So it doesn't matter if it's curved or not, okay? So it's a closed curve that divides the plane into two regions, an interior and an exterior. Well, I thought the interior was not part of the circle, okay? In everyday use, the term circle may be used interchangeably to refer to either the boundary of the figure or to the whole figure, including its interior. In strict technical usage, oh, we're getting technical here, the circle is only the boundary and the whole figure is called a disk. So these people are saying that the boundary, that the circle is the circumference. Bunch of dots going around, they're all discrete dots, they're not connected, there's space between each dot, otherwise we can't talk about a dot or location, because the location of whatever has a certain size, you could say, you know, the size of the thing that occupies the location. Okay, so there is no such thing as a spread out location. The location is here, and the location, as they always put it, they use an ordered pair or a triplet or whatever, okay? But yeah, it's made out of points, and those points, dots, right, are representing locations. So a circumference is just a bunch of locations, and they're saying that the circle is a bunch of locations. And so the guy on the right is known as a disk, the guy on the left is known as a circumference. What the hell do we need the word circle for at all? We already have the word for what they call a circle, it's called circumference. And we already have the word for disk, which is the guy on the right. So what do we need the word circle for? Okay, and this is part of the problem, because they jump back and forth. They point to that and say, well, that's a circle, and that's what everybody understands by a circle, but the circle is really the circumference. So which is it? Why do we need the word circle? We don't need it in science at all if they're going to go back and forth. And it turns out that, you know, the circle is more like this. That's a circle. Because they say it is the curve traced out by a point that moves in a plane, so that its distance from a given point is constant. So we have the point, which is a location, and the location is moving around. They represent the location with a dot, and they say don't pay attention to the dot, but that's what they're showing. In other words, the so-called circle is an orbit. That's what it is. It's not is that a geometric figure? Are you staring at a geometric figure? And I don't mean the blue ball. I'm talking about what the blue ball is describing. Is that a circle? But that's what we have as far as definitions. This is strictly from the definitions. I didn't invent this stuff, okay? This is what they say is a circle. So, yeah, we have a little bit of problem with what all these people are saying, because their definitions first don't match geometry, which is figures, first and foremost about figures, objects, things. And second, they're talking about motion. Then they're using these words in a very deceptive way, okay, whether knowingly or not. They put a dot to represent the location, and they call it a point. And so you don't know if the point is the dot or the location. And they build the geometric figures with dots, but then they say, well, it's just a bunch of locations. So here you have a cube, or a sphere for that matter, and what you have is locations. And yeah, they say between any two locations you can have another location, meaning that between any 2 points you can have another point. And they do all these fancy things because they're not talking about points, which what a normal sane human being understands by the word point, which is a dot. That's not what it is in geometry. In geometry, it's a location. In other words, they're not talking about geometric figures at all. Okay, let's continue here. Here's a square, which is the subject of today. Is that the square? Absolutely not. This is the square. If I can get it up here, give me a second. This is the square, okay? That's a square. A square is a dot moving all around, and it's not even a dot. It's a location that's moving from location to location. That's what a square is. Okay, so if you thought that the square was the guy on the left, well, you didn't understand what you didn't read. You have problems with reading comprehension. Okay, this is a square. Square is a bunch of dots that go around. Okay, and it's a perimeter, you could say. In best case scenario, you can draw them all in there and just make your little square with dots. But the square, above all, is not a continuous figure, which is what Euclid tried to define at least. He said it's continuous. These people don't have that. They say it's made of points. In fact, Euclid said the same thing for that matter, because he built his planes with dots, with lines. And what are lines? Dots. Bunch of dots. And what are the bunch of dots? They're a bunch of locations. So we don't have anything in front of us because there's no physical entity in front of us. There's no object, no shape, no figure. All we have in front of us are locations, and what they do is they set them in motion. So when you see a location moving from location to location, well, that's called a line. And if it's curved, they call it a curved line or a curve, and so on. So we're talking about motion of locations from location to location. That's what geometry is. That's what a square is. That's what a circle is. Okay? Semicircles also. Okay, what should we conclude? Oh no, I got another one here just in case. Okay. You could fill it in, leave it there, say that's a square. Okay, that's another version of the square. Okay, but really, no, it's just a moving location. That's all it is. The mathematicians don't care about figures. Mathematics has no use for figures. Mathematics has no use for objects. They can't put the word dog in an equation. They can't put the word rock in an equation. They have to put the mass of the dog or the size of the rock or the volume of the tree. They have to put numbers in there with units. So math has no use for objects. That's why the mathematicians are the least skilled people to do physics. They have no clue whatsoever how to give a physical interpretation to anything. In fact, they have no problem giving you an irrational explanation because that's what their equations tell them. That's their interpretation of their equation. So they don't care about the physical world. Physics for them is alien, completely alien. All they want to do is equations. And then they give you an irrational physical interpretation, and people think they're so smart because they know how to read those hieroglyphics. That's the only reason. They say, oh, he knows how to read all that stuff. He must be a genius. No, he must be a genius for that, which is more like autism, because a guy who goes into so much detail in mathematics has a problem, a mental problem, really. But then, that guy is totally unqualified to give you a physical interpretation. And that's the status of so-called mathematical physics today. Okay. Let me give you a conclusion here. Well, I've got, before I get to that, let me show you a few questions that people raised. This is regarding the circle and applies to the square as well. And they're important questions. These are questions that people pop up with, when they say, well, hold it, how about the circle this and how about that? And so it's important to fill in these blanks. Okay, so let's cover this before I move to my summary, my conclusions. Okay, this fellow says the following. He says, I don't understand why I can see spaces in that diagram labeled circumferences and disk, which I showed the other day, which is the one on the bottom. Okay, so we have circumference, we have disk, and I'm saying, what the hell do we need the word circle for if we have a word for circumference, which is what they say the circle is. We have a word for the disk. What else is there? So we don't need the word circle. And he says, I can't see, why I can see spaces in that diagram space labeled circumference and disk anywhere on that set where you can see space There should obviously be another point. No, that diagram is a total failure. Well, so what is he saying? Well, he's saying this. See if I can get this thing up here. Give me a second here. Okay, this is what he's saying. He's saying, what if we put dots in there, right? He's saying there should be no spaces because everything should be covered by dots, whether you talk about the disk or the circumference. And the answer is no. The answer is that if you're going to talk about dots, okay, if they're discrete dots, there's got to be space all around it. Sorry. So there's got to be space, and you can put another dot between any two dots. You're still going to have space between two dots, no matter what. Otherwise, you don't have one dot, you have two dots merged. You have a single piece dot, so to speak, two dots that merged into one. And that's not the case because a dot is a discrete entity. So if you've got that, you can put as many dots as you want between any two dots. You're going to find space anyways. So no, you can't fill it with dots. Every time you put a dot in there, that dot has to have space all around it to contour it. Otherwise, you cannot talk about the word dot. Okay? And it gets worse when you say, well, I wasn't talking about dots anyways. I was talking about a point. And what is the point? Well, the point is a location. And so what contours a location? Space? Well, you know, locations don't have dimensions, and they're not really objects. They're not figures, okay? So you can't use the word dot if you're going to use the word location, if it's a synonym of location. So either you use the dot and you have space all around it, or you use the word location, in which case you have absolutely nothing, okay? Because location is a concept, it's not a figure. It doesn't have contour, it doesn't have anything surrounding it. Okay, so we got to get all these things in the right context. Okay, and the fellow keeps going, and he says, he continues, he says the following. He says, here's another word you should look up, continuum. Oh my God. He touched the raw nerve there. Continuum, okay? Well, I think the guy who's got to look up the word is him. I don't think he has the slightest clue what a continuum means, just like the square. People think a continuum is a continuum, and it's not. In the religion of mathematics, in the religion of geometry, in the religion of mathematical physics, continuum means discrete, means segmented, means made of parts. That's what continuous means, and that's what continuum means, okay? Evidence, proof, let's do it. Let's provide evidence. In fact, someone else doubled up on him and said the following also. My God, these poor people. What you do not understand about continuous line, I understand it. Although it is not used in geometry. Oh, very interesting that he said that. Yeah, it's not used at all. Why would anybody invent the word that he's not going to use, and he's going to say, well, the line is continuous, but I'm not going to use it at all. Okay? But he says that. It's good that he says that, but he doesn't realize his contradiction. Okay? A solid line is different from a broken line. Well, yeah, I know it is. I'm just saying that there is no such thing as a solid line in all of mathematics, in all of mathematical physics, and in all of geometry. There's no such thing as a solid line. Line is made of points. The word line means made of points, which are what? Locations. That's what you don't understand, okay? I understand what continuous means because I talk about objects. These people have no clue because they don't talk about objects. They're not talking about figures. They're not talking about geometries. They're talking about concepts, about motion, about locations. That's not a geometric figure. That's what you don't understand. Okay, so keep that in mind. Since the circle is an imaginary figure, okay, so-called figure made of locations, is that what a circle is made of? That can only be drawn, saying that it is a continuous line does not seem inappropriate or wrong to me. Well, again, because these people don't do any reading comprehension, they just swallow this stuff and they have no clue whatsoever what they're saying. Okay? This is where the problem is. They just regurgitate what they heard out there, what their teacher taught them or whatever. Okay, so let's find out. Let's provide some proof and evidence that continuous means segmented, made of little points, chopped pieces. That's what continuum means in the religion of mathematical physics and in mathematics and in geometry. They never were able to define these words properly. Okay, here's a continuum according to math. This is the math part. In the mathematical field of set theory, the continuum means what? The real numbers. That's what continuum means. What are numbers? Well, hopefully they're all discrete because the 5 comes after 4 and before the 6, so they're all kind of chopped separately, okay? So if they're numbers, what kind of continuum is that? And then between any real number, you can fit a decimal point, obviously. But even if we talk about real numbers, it's chopped off. What are you counting? You're counting sheep. Well, hopefully the sheep are segmented. You know, they're discrete. So continuum means a whole bunch of sheep that you count. 1, 2, 3, 4, 5, 6, 7. So that's a continuum to a mathematician. What's another notion? The real line. What is a real line? Well, it's the real numbers. Again, bunch of numbers. That's what continuum means. Another one in point set topology. Okay, a continuum is what? Is a non-empty, compact, connected metric space. So if it's connected, you're connecting two things. Obviously, it's not continuum. It's discrete. It's segmented. It's made of pieces, of parts. Okay, what's a metric space? In mathematics, a metric space is what? A set together with a metric on the set. The metric is a function that defines a concept of what? Distance. Distance between what? Between any two members of the set. So a continuum means that it's made of a bunch of discrete parts. That's what a continuum means in mathematics, which are usually called what? Points. What is a point? A location. How many locations are there? Well, it depends on how many times a kangaroo jumped. Summary in mathematics, in the religion of geometry. It's a religion. It's irrational. Continuous means segmented, discrete, made of parts. That's what continuum means. That's what all these people don't understand. They tell me to go look up the word continuum. They should look it up. Okay? Okay, and here we have another evidence, proof. Okay, so people read for a change. Okay, sometimes I try to chop these things off. People get upset when I do that. I should do that because people don't know how to read. They don't understand what they're reading. They get bamboozled by all the wording and they lose the real meaning that's encapsulated in that sentence. A continuum that contains more than what? One point is called a non-degenerate. I think the degenerates are others. Mathematicians are degenerate. More than one point. That's what continuum means. Okay? A subset A of a continuum. What do you mean a subset? I thought continuum was made of a single piece. They say that's a subset is part of a continuum. Continuum X is homogeneous if for every, what? 2 points, blah, 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 blah. So we're talking about many points. What are points? Locations. So we're talking about many locations. That's what a continuum is. They're talking about motion, continuous motion, if anything. Okay? Really, it's not continuous because continuous is an adjective. You cannot use adjectives in physics. In physics, not in ordinary speech. In physics, you cannot use an adjective to qualify motion. These people are qualifying motion with the word continuous, and then they ended up with this noun called continuum. Like they used the word infinite, and then they ended up with infinity. Same thing. They turned the adjective into a noun. No, it's if it's connected at each point and you're talking about numbers or whatever, then you're not talking about a continuum. You're talking about segmented. You're talking about many pieces. A one-dimensional continuum is often called a what? A curve. What is a curve? A bunch of points. That's what what are the points? Locations. That's what a curve is. They're talking about motion. So they talk about continuous motion when in reality it's incessant motion is the correct word. The rabbit is moving incessantly. Then you can use it like that. That's the way. You should use adverbs for motion. adjectives are for objects, to describe objects. And as long as we keep it there, we're okay. It's when we start mixing these things up and use ordinary speech and bring that into physics, that's when people get lost altogether. Again, summary: in mathematics, continuous equals segmented, discrete, made of parts. No matter how you twist and turn it, there's no such thing as continuum in mathematics. Okay, and here's the physics part. We have to have physics also, right? That was the mathematical part. This is the so-called physics. It's called mathematical physics, which ain't physics at all. And here it is. First one is from the Wikipedia, okay? A geometric interpretation of special relativity that fused time into three spatial dimensions. They're talking about space-time, right? Of space into a single four-dimensional what? Continuum. Okay, so we have a four-dimensional continuum. You would think it's a continuous sheet of some kind, okay? A space-time continuum, right, is mathematically defined as a four-dimensional smooth connected manifold. Connected? What do you mean connected? I thought you said smooth, made of a single piece. And no, what is a manifold? About each point, event on this manifold, blah, 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 blah. So the manifold is made of points, and a point is, what is it, a dot? Is it a location? No, now an event is a point. In other words, the so-called location somehow turned into a happening, an occurrence, something that motion within a single frame of the movie, of the universal movie. We have motion. Okay, that's what they're saying is a point. A point is now an event, something that happened. A manifold is a topological space that locally resembles Euclidean space, meaning that if you make it small enough, it's flat, okay, near each point. Okay? And what does good old Mr. Stephen Hawking say? Okay, well, he says something horrendous. He says space-time. This is out of his book, Glossary, famous book, A Brief History of Time. The four-dimensional space whose points are events. That's what space-time is. What is an event? A point in space-time, specified by its time and place. So we have a problem because these people went further than good old Euclid. It was bad enough when they said, well, the point is really a location. It's this abstraction called a location, and we specify it with an ordered pair or a triplet or whatever, okay? And now these people are saying, no, you're wrong. The point is an event. It's something that happened there. We have a movie within a photograph, within a snapshot. So that's what, in a nutshell, what mathematical physics and geometry has become. Okay, so we look up continuum in the Wikipedia. And this is what we find. A continuum is what? A body that can be what? Continually subdivided into infinitesimal elements. That's what a continuum is for physics, according to the religion of mathematics. Okay, this is what they came up with after hundreds and thousands of years of thinking, of brainstorming, whatever. And if you don't believe these folks, the people in the Wikipedia, here you have good old Aristotle. Okay? Good old Ari, he gave it his best shot. This is where it all came from. See, all these people started following Aristotle, and they came up with not the same nonsense or even worse nonsense than what Aristotle came up with. What does Aristotle say about continuum? He says, this is out of his book Physics, book 6, things being continuous, okay, if their extremities are one. Their extremities are one. Okay. Nothing that is continuous can be composed of indivisibles. Okay. Well, I thought that nothing that can be continuous can be composed of anything, let alone indivisible. Should not be composed of anything. It should be made of a single piece. That's what continuous means. Example, a line cannot be composed of points. That's what Aristotle said. A line is not made of points, according to him. Okay. But let's wait. He's not finished yet. The line being continuous and the point indivisible. So he's saying that the line cannot be composed of points because points are indivisible, and that which is continuous cannot be made of stuff that is indivisible. It has to be divisible. You should be able to chop it. And if the point, which is that which has no part, cannot be divided, it's indivisible, then it cannot form part of a continuous structure. So now he's contradicting himself, because he gives us the notion that a line is continuous because it's not made of points, because the point is indivisible, and it's got to be divisible in order to be part of something that is continuous, which is the line. And then he says, but he's telling us that it can't be made of a point only because the point is indivisible. Okay, keep that in mind. Okay? But the line is going to be made of something, but it's not of that which is indivisible. That's what he's trying to say here. Okay, since indivisibles have no part, they must be in contact with one another as whole with whole. Right? He's saying if you got two apples, they got to be in contact with each other, but you should be able to chop the apple in half. If you cannot chop the apple in half, in this case the point, because it has no volume, no dimensions, no nothing, okay, you can't chop that which is nothing in half, okay, then he's saying they could come together if they were divisible, but since they're indivisible, they can't come together. But this is how he ends up his analysis. He says, if they are in contact with one another, they will not be continuous. For that which is continuous has what? Distinct parts. So what has he chased his tail completely around? He says that which is continuous is made of distinct parts. Well, what parts is a line made of? If not points, if not these locations, these events. So he says that which is continuous, it has distinct parts. So he starts out by saying that continuous has to be made of a single piece. Essentially, it can't be made of points, but then he ends saying it has to be made of distinct parts. And I don't know what else it could be made of if other than points. That's the only other geometry which is smaller or more basic than the line. What has Aristotle said? And just in case you say, well, Bill, you misinterpreted. Okay, I always get accused of misinterpreting everything, reading everything wrong, okay? Just the story of my life. So here's Mr. Hawking, Stephen Hawking. He's going to tell us what Aristotle said in his own words here. He says, Aristotle believed, that's also out of A Brief History of Time, believed that matter was what? Continuous. Okay? That is, one could divide a piece of matter into smaller and smaller bits without any limit. One never came up against a grain of matter that could not be divided further. So yeah, that is what Aristotle says, that continuous is something you can chop into pieces. Well, I thought that was what is not continuous. That's the opposite of continuous. That's segmented. If you can chop it, it's segmented, made of pieces. So all these people have all these notions completely bunk. You know, they're all nonsense. All the terms defined in geometry are nonsense, all of them. And so we don't have really a rational geometry. And you might say, well, Bill, we've got this far with all these geometric figures and definitions, and look at all the stuff we invented and blah, blah, blah. Because of geometry, we ended up with space-time, which is a geometric theory of gravity, of macrogravity out there. So you better pay attention, because it's because of geometry that we have space-time, that we ended up with all this mathematical nonsense, that we ended up with a black hole which is zero-dimensional, and they call it an object. They think it's a thing, it's a figure, it's a whatchamacallit. No, if it's zero-dimensional because the star that made that black hole collapsed to zero size, zero volume, like Mr. Chandrasekhar said, and got a Nobel for saying that, for coming up with equations showing that a black hole collapses to what? Zero size. We have nothing, absolutely nothing in front of us. And they say, well, it's got infinite mass, because you got all this mass and it's in zero volume, so that's approaching infinite mass. Well, that's all nonsense. Infinite density, I'm sorry. That's all nonsense. Uh, we're talking about physics. We want to know what physical object is in there. And if they say it's zero dimensional, zero size, no radius, no diameter, then we're not talking about an object. We're talking about nothing. There's no difference between space, which is nothing, and what you just described as a black hole. Where did they get all this stuff? From geometry. So yeah, I do attack geometry, and I call it a religion because it ended up with general relativity, and it also with quantum mechanics. And now what do you think string theory is doing? The same thing. They're using geometry. What are they using? Are they using, what are these strings? Are they strings like, this is a string, you know, like this one that I showed a minute ago? Is that what it is? Let's see, here it is. There we go. Is that what string theory is? Absolutely not. They're talking about lines. What is a line? Line's a bunch of locations. What is a bunch of locations? An itinerary. That's what string theory is. They should call it itinerary theory so that you don't get misled. See, every time these people talk about strings, people say, oh, I know what that is. I know what a string is. No, that's not what these people are talking about. They're talking about itineraries, closed loop itineraries, which they claim that because these closed loop itineraries, locations, vibrate, they form particles. So the particles are made of locations that are vibrating. Okay, you got that? I hope you can take that with you to the bank. Okay. Okay, so I think I have one more. Yeah, just wanted to show you this. All these people like Hawking and Niels Bohr and Feynman, Einstein, all these, they followed Aristotle. If anything, they modified Aristotle a little bit here and there and just made it worse, but they all essentially learned their geometry from Aristotle. And so here's a synthesis of that. Okay, here's all the mathematicians are blind and they're following a blind man. Okay, that's what happened. All we have is the blind following the blind, or the blind leading the blind. Okay, so let's go with my conclusions. Okay, here it is. Geometers since the days of the Greeks, right? Aristotle, Plato, all these great poets misconceived all geometric figures, all of them, especially the planes and below, like line and the point, because you know none of them are objects, none of them are figures. What they are is motion. They are locations. That's all they are. And location is not a geometric figure. Because Mr. Aristotle defined, these guys don't define it today, but Mr. Aristotle defined figure as that which has shape, that which has a boundary. Okay, and this is not what they're talking about at all. They're talking about locations and motion. Geometry has never been the study of shapes. Never. Mathematicians have no use for shapes. They have no use for the circle, the real honest to goodness circle. Here, I'll show you sideways so it won't blind you. This is a circle. And I mean, well, it's a three-dimensional circle. It's got some width, but you know what I'm talking about. The point is, mathematicians have no use for this, for a circle. They have no use for squares. They have no use for semicircles. They have no use for triangles. They have no use for any of these figures. What are they going to do with it? No, what they want to look at is relations. They want to look at angles. They want to use the size, dimensions of something, you know. That's what they're looking at. They're not looking at the figure itself. They don't care about the figure. They're just going to put a dotted line and say, well, this is how much I measured. They're going to represent that with a line. What is the line? It's just the unrolling of the measuring tape. That's all it is. Mathematics has no use for shapes. Okay? Geometry deals exclusively with motion. Geometry meaning what these people do. Okay? They only deal with motion. Geometry has always analyzed, compared dynamic relations, in other words, measurements. Geometry is the vain attempt to merge mathematics and physics. Math is math, physics is physics, never the twain shall meet. And so, you know, math cannot help physics at all. Physics is about explaining a mechanism. We don't need any math whatsoever. At all. We have no use whatsoever for math. I mean, you can describe with math, fine. You know, you want to say, well, what is the acceleration of gravity? You see 9.8 meters per second square here on Earth, fine. That's a description. You haven't done physics yet. All you've done is math. All you said is, yeah, this is the acceleration. That's a number. What is the speed of light? 300,000 kilometers per second. What is that? Did you explain anything with that? No. That's just a measurement. That's just a number. You have not. That's a description. You haven't explained anything with that yet. The fact that in physics we say it much swifter. We say light is fast. Now, how's that for accuracy and precision? It's fast. That's all we need to know. It's fast. Now please tell us what light is and why it does the slit experiment and why it does, polarization. That's what we want to understand. But to tell me that light is fast and that what a photon can be at two places at once, well, we don't care about those kinds of explanations. But those are the explanations. Who gives those explanations? Mathematicians, geometers, these mathematical physicists, so-called physicists. Geometry, there you have it, divided into mathematics, which is relations, and physics, which are the figures. And what the Greeks try to do is blend them together. And you can't blend mathematics with physics. One has nothing at all to do with the other. Okay, so this is my conclusion on that. Okay, why don't we get into some of the questions, comments that people made. And again, a lot of it has to do with understanding what physics is about. And some of these people have no idea what physics is about. And all they want to do is preserve their religions. And so I ask them, look, an object is that which has shape. And I justify it. I'm saying that's the only, like I did before, that's the only property all objects have universally, etc., etc., etc. And I justify each statement. And they say, well, no, you're wrong, Bill. That's not what an object is. Okay, what is an object in the alternative for the purposes of physics? And so the main one is see-touch. And yeah, of course, they can't defend see-touch. And so they never do defend see-touch. The only defense they have is it's tradition. We learned it from authority. I memorized it when I was at the monastery. Okay, great. But you can't defend that. You can't defend the see-touch because you can't see the air, and the air is made out of atoms, and the atoms hopefully are objects. So what do you have? Air is not an object, even though it's made out of atoms. It's something that blew your house away, the tornado, and all that air was nothing. So, you got to define what an object is, and you got to define what a concept is. You can't say a concept blew your house away. Not in physics. Maybe outside in ordinary speech you can say that. You can say love moves mountains. You can't use that terminology in physics. Physics, you got to have a physical object if you want to move in a mountain, okay? And that's the way it works. Okay, and so one fellow says, pointing with a finger always imply the human senses. My God. What are you going to tell this poor fellow? I mean, he's completely out of it. Doesn't even have a notion of what we're talking about. When we say observer, we're talking about theories, okay? And pointing is not the definition of an object. What we're saying is that an object is that which you point to. If you're going to teach the word tree or the word square to an ET, someone who doesn't know your language, you say tree and you point. Is that observer? Well, if we die, is the tree still there? The tree stands alone without me. The fact that I point is just to name it, just so the guy understands the language. What problem do you have? You got a mental problem. Some of these people really have, something so simple that they cannot really understand. For me, it's mind-blowing that they cannot understand something so straightforward, so simple. Okay, another fellow, he tries to analyze me. Okay, I need a psychoanalysis. Okay, what does this guy say? He says, Religion, assume there is a God, mechanism of world creation equal God did it, and conclusion, I believe God created our world. Okay, that's what he thinks religion is. Okay, and then he says, this is how Bill does it with the rope model. He says, assume there's a thread, mechanism of world creation. Have no idea where he got that at all. I don't use creation at all. Thread intertwines to give a rope with the thread having two different properties. Don't ask how. And that leads to objects in the universe. That lead to objects in the universe. And conclusion, believe in my model. I am God's prophet. He didn't even, obviously he's not a very educated guy. He misspelled prophet, prophet on earth, who cannot be questioned by experimentation or any other scientific process. Well, experimentation is not a scientific process. It has nothing to do with science, because the only purpose of experiments are to persuade and convince the jury. And we don't do that in science. That's why we don't believe, or, he's putting words in my mouth. So let's put the Bill version here, okay? This is the real version so that people understand what I propose compared to what this bean brain here put out there, which is nonsense. He's just upset that he has no arguments. Okay, and that's why he's got to say something. That's the nonsense he said. No, this is the Bill, the real Bill. Okay, here. Assumptions. Assume there's a pair of twined threads, a rope, which I'm pointing to. Okay, I point to the rope here. I even this is what I'm saying. Two twined threads, a rope. Any questions of what I'm talking about? I'm talking about a rope, twined threads. Looks like DNA. I don't know how else to. If you don't understand what I just by showing and tell you what you're staring at, I don't know how else to present it. But this fellow apparently, has a mental block. He doesn't know what a rope is, or he doesn't know what I'm talking about. So I don't know. I'll show it. Here I drew it. Okay. I don't know how else to present it so he understands what a rope is. Okay. Okay. And assume the atom is a ball made of these same threads. There you see it on the bottom. 3-dimensional on the right, 2-dimensional on the left. Okay, I'm pointing to all atoms are interconnected. I'm not sure what people would not understand about that. What part do you not understand so far? Is this over your head? I mean, maybe this guy has a mental capacity of a 2-year-old. I don't know. Maybe he's autistic. All kinds of people out there. I mean, what part don't you understand about this? I'm saying that there's two threads. They're twined, okay, and they fork out at the boundary of the electron shell. Okay, they can move around. They form the atom, which, when it expands and contracts, torques the rope. That's what I'm saying here. What part of that don't you understand? Even before that, I mean, just don't you understand what I'm saying? You got two balls and they're connected by a rope. I mean, I don't know what else to do to have you understand my assumption. Because look at what he said again. I mean, this is what this fellow says. He says, a thread intertwines to give a rope with a thread having two different properties. I don't know why he talks properties. We're not there yet. We're just trying to understand what I'm presenting. I'm saying that there's two threads, two twined threads, and that leads to objects in the universe. And there it leads to objects, to the atoms. And he doesn't understand that. He doesn't comprehend something as simple as that. Okay, let's look at the mechanism now. He talks about a mechanism of creation. I'm not sure where he got that. Obviously, he's talking about some other site, not this one. Induced by the tug of all atoms in existence, our atom expands and contracts. Okay, so here we have a little atom. Okay, it expands and contracts. I just want you to understand the mechanism. I don't want you to believe in it. I don't want you to criticize it yet. I just want you to understand it. Right now we're talking about understanding. Right now this fellow doesn't have the mental capacity to understand this. This is what's incredible. By doing so, it torques the rope. So here you have this thing that's made out of the same threads. When it expands, it torques the rope. The torsion moves along, the rope. What part of that he cannot understand is just beyond me. Okay. Torsion propagates along the rope to the next atom and stimulates it to expand and contract as well. So by expanding here, torques the rope and triggers the other atom to do the same. So if this one's doing it faster, it'll trigger the other one to do it faster as well. Torsion along the rope is what we call light, and the thump that the atom comprising our eyes receives is how we detect light. That's the mechanism. That's the theory that I'm presenting. What part did you not understand? I mean, right now we're talking about understanding. I don't care if you believe in it, that doesn't enter the picture. I just need to know if you understood it. And right now this person, this individual, he doesn't understand this. He's got a mental problem. He says he's a teacher. I don't know who he teaches, maybe retarded children at a mental asylum. I don't know who he teaches. What could he teach? What can he possibly teach? He can't understand this. And I think this is baby stuff. I think a 10-year-old can understand this. Okay. And so he continues. Oh no, well, this is my conclusion on that. Okay, and it goes like this. These are the conclusions for the rope. We have now illustrated a mechanism of how light propagates along a physical mediator. Hopefully, light is mediated by a physical object because you can't do physics without an object. So you need an object in there. Otherwise, you're doing magic. You're doing spirits. So there better be an object that mediates light. Let's get that straight, okay? And quantum does it with particles, but their particles are not particles. So quantum doesn't count. Relativity also uses the same, they say it's photons. What are photons? Well, numbers. That's what they are. They move numbers around. So, and the people who propose ether, which are usually the dissidents, what they are using is particles, but they use real corpuscles. And they have these corpuscles moving up and down, waving. They say that's light. So, yeah, that doesn't work either because you got to explain why the particle goes up and why it goes down. What forms that wave in the ether? That's what you got to explain. Does a particle pull on the other particle when they go up in the sine wave? You know, it has that siney wavy thingy, right? So one particle pulls on the other one. Why would it go up in the first place? Okay, so are they tied together, all these particles, all these ether particles? So these are the issues that an etherist cannot explain, a guy who does it with real corpuscles. And quantum does it without corpuscles. They just use numbers. They don't use physical objects at all. That's why it's not part of physics. Okay, and so, you know, again, that's the, I've illustrated the mechanism so that you understand it, okay, so that you comprehend it. What part you don't understand means that you have the mentality of a 5-year-old or less. Maybe that's why you don't understand it. What part can't you understand of how light propagates, you know, along a rope when I'm saying it's a torsion that moves along a rope? What part? I mean, here, let me illustrate it. This is light. You know, see if I can torque it in. I can't torque it at the speed of light, but that's what I'm saying. That's what it is. What part don't you understand about that? That's all I want to know. What part don't you understand? Not that you believe. I just want you to understand the mechanism. And right now, these people can't understand the mechanism. Okay, along a physical mediator, there's also the mediator of action at a distance, phenomena such as gravity. So this one not only does light propagate through the rope, but the ropes, all the ropes because all atoms are interconnected, those are what are going to produce gravity. Okay, religion. Again, whether you believe in the objective mechanism just illustrated is of no concern to science. So we don't care about your belief. Okay, and there is no experiment you can run. Okay, an experiment cannot tell us anything about an invisible, intangible entity such as the mediator of light. Here's light, you know, and I can pass my hand, I don't touch light. Okay, so I can't touch or see it. Does that mean that there's no object there that mediates light? Is that what you're saying? You're saying that's done with spirits? When we shine our laser to the moon, to the Lunar Ranger experiment, right, to this mirror that we put on the moon, we shine a laser. What's going through space? Nothing? Just a ghost? Hopefully you've got something going, you know, from the laser pointer to the mirror. Hopefully there's something in between there. And what you got to tell me is what mediates light. What is the mediator of light? If you can't tell me that, get out of physics, stay with religion. Don't tell me that there's nothing there. There is something there. We can't see it or touch it, but there's something that mediates light. And for hundreds of years, they used the particle. Then they gave up on the corpuscle. It's called a corpuscle, the classical particle. And then they went into quantum mechanics. They say, we forgot about, completely about the objects. We don't care about that anymore. We're just going to describe it mathematically. And of course, they used a photon, but the photon is just a number. And, that's how they came up with virtual photons. They can create them out of, the mathematical mind. They just create them to fill the equation. That's very easy. And the only purpose of an experiment is evidence. Okay, that's the only reason people do experiments, is for evidence, not for, in other words, it attacks belief, opinion. It doesn't explain anything objectively. Explain, you have to explain it separately. The experiment's not an explanation. The experiment, here's an experiment. I let go of the pen, okay, and it falls down to the floor. Okay, there's the experiment. You want me to do it 1,000,000 times so it's repeatable and it's scientific? Fine, I'll do it 1,000,000 times. Now, please explain to me why. What caused it to fall? That's what you got to tell me. Doing experiments will not tell us anything. They've been doing experiments on gravity for who knows how long, and no one can tell you what gravity is. In fact, quantum doesn't even have the graviton yet. It doesn't have the particle of gravity in its standard model. And they've done all kinds of experiments. What other experiment do you need to run in order to tell me, how the graviton does it? How are you going to explain that with a graviton? You can't. You can't explain it with particles. Okay? Gravity is a tug of some kind. It's the pen is somehow pulled towards the earth, to the center of the earth. And you got to tell me what the mediator of gravity is before you even tell me your theory. Because otherwise you're going to be doing magic, black magic, if you don't put a mediator there. Physics is done with objects. You can't do physics without objects. You need an object for gravity. You need an object for light. You need an object for electricity. And you need an object for magnetism, for all this stuff. You can't do it without objects. And that's what these people don't understand. They want to do it without objects. And they say, well, an object's that which you can see and touch. Why? Because that's what they do with experiments. And experiments cannot tell us anything about invisible, intangible mediators. And if you don't put a mediator, you're doing it with spirits. Okay, so that's the logic behind that. And no, we don't care about authority. We don't care how many mathematicians voted for a given theory. Plays no role whatsoever in science. Okay, here's a continuation to that. This is what mathematical physics really does. And this is what this fellow did not really address, what mathematical physics does. And here it is. They assume there are particles, which ain't particles, but rather equations. Let's call them fields or waves or energy, or there's just virtual particles to mislead and confuse the gullible idiots who know nothing about math and swallow this stuff like candy on the basis of our authority. We'll just brush aside challenges of skeptics saying that physical interpretations belong in what? In philosophy. Mechanism of how two real photons morph into two virtual photons. This we had the other day, and it goes like this, more or less. The photon particle, which ain't a particle, okay, splits into a negative electron particle, which ain't a particle, and a positive positron particle, which also ain't a particle. We have no clue what negative and positive mean in physical terms, but let's roll along since the gullible idiots never ask. I mean, what is it this fellow ask? What does negative and positive mean? What in physical terms? That's what we need to find out. We need to find out why negative attracts positive, not just state it and say, well, X attracts Y. Yeah, but you need to tell me why. What causes X to attract Y? If you can't tell me what causes, what does it matter if you name one X and the other one Y? The positron virtual field bangs against the electron virtual energy, both of which popped out of the vacuum through a mechanism that we will explain in our lecture scheduled for the year 3001. And the wave function collapses into photon balls, which ain't balls but rather equations or points or ether or something like that. This is what these people say. This is their explanations. explanation in this case for how a photon morphs into two virtual photons. They go through this whole rigmarole and they do experiments. They did 100 experiments on this, and they came up with this nonsense. They come up with virtual photons. What else can they come up with? And this guy believes all this stuff on the basis of authority only, because they say, oh, those scientists, the scientists. Scientists, my foot. You know, these people are not scientists. Anyone who talks about virtual particles is a religious idiot. That's how he should be treated. That's the correct word. I'm sorry. I got to treat them with the respect that they deserve. Don't tell me a particle can be at two places at once. Don't tell me that virtual particles pop in from the void and then they go back and recombine negative with positive. Especially if you don't know what negative and positive mean. Okay? So yeah, it's all these people who just swallow this stuff, but like candy, they have no ability to think beyond what the authorities tell them to believe. And they just believe it and they say, well, but they're running experiments and look at all those equations. Who understands all that? Thank God they understand it. Again, you can sell them the Empire State Building twice. Okay, the important part is that we proved experimentally. This is how they would end their conclusions, right? This is how they usually talk. Through direct observation of the photon balls, direct observations of the photons. See, they use that word observation. These people are so gullible, they accept it. What do you mean observation? You mean like with your eyes? Is that what you meant by observation? Why do they use the word observation? Because it insinuates that they have proof that they saw it with their own eyes. That's why they use the word observation. They have all these, words out there that they've created, these, what's the word I'm looking for? These misleading terms that they use out there. Okay, in the lab, through direct observation of the photon balls, which ain't balls, that two photon balls morph into a virtual fields or energy or wave or functions and back again, you should believe our findings. Why? Because we've got jobs and you don't. Our gold medals given to us by our peers prove it. Okay, and what do you have? How many of our peers voted for your skepticism? That's essentially what they're telling you. All these so-called mathematical physicists, they call themselves scientists. Nevertheless, you wouldn't have that computer you're typing on if it weren't for that our theory is correct. They think that technology proves that a particle can be at two places at once. That's what we have from mathematical physics today. And these people just swallow it. I mean, they have no problem swallowing this stuff, and you tell them, look, try to open your eyes, you're hypnotized, you're believing all this stuff that a particle can be at two places at once. Yeah, they proved it with an experiment. See, science is about running experiments. Well, here, they ran experiments. This is the nonsense they came up with, that a particle can be at two places at once. And these people actually believe this stuff. They believe a particle can be at two places at once, and that the star collapsed into a black hole, and they said, yeah, it's a zero-dimensional nothing, and it swallows other stars, swallows matter. Okay, and this guy makes another comment, another criticism there. Okay, good, let him come. Says, fields, what is a field? Are numbers or vectors? Yeah, numbers and direction, but they represent actual physical things. Like what? Please tell me what physical thing. Please tell me what a thing is first, but then what physical things do fields represent? Don't just leave us there hanging, from a cliff. Tell us exactly. Draw it. What does the field represent? What physical thing? What is a physical thing? And it turns out that he gives a couple of references. Videos on what a field is. What is a field? Okay, fine. We can get to a field. Let's find out what a field is. Well, the first guy he references is this fellow Nick Lucid, which I talked about a little while ago. And this fellow doesn't have the slightest clue what physics is about. He looks like Curly. I call him Curly. Okay, shaved his head or whatever. And this is what good old Nick says. Okay, he has this. He starts out by saying he has this y and x axis. I don't know why he needs that at all. But here's the key issue. What are those little numbers that you see there? Those little things? I don't know if you can see them well, so let me expand them. That's what they are. They're numbers. A field is a bunch of numbers. So this fellow says that they represent real things. Well, I don't know what real thing is because everybody puts numbers whenever they talk about a field. In fact, a field is a bunch of numbers. That's all it is. And here we have another fellow that he referenced, the other fellow here. And this fellow, his name is Ed Rennie. And what does this guy say? Well, he says, a field is a region. Well, is a region a physical object? Is that the object, the physical object that this other fellow is talking about? A region? A region of the hand is the palm. So is the palm, as a region of the hand, is the palm in that context, is that a physical object? No, of course not. A region is never a physical standalone object. A region is always of something else. China is a region of the planet. Okay, it's got to be of something else. So if a field is a region, obviously it's not a standalone object, cannot be confused for a thing. You got to tell me what thing, what physical object, as he said there, it represents. Hopefully he'll answer the question. More than likely he'll run away and just give us more runaround. He'll say, well, it's a bunch of numbers. Yeah, if they represent a physical thing, just tell me the physical thing it represents. You got to tell me what a physical thing is, okay? You got to define that term because the definition of the word thing destroys your religion. Okay? You got to tell me what thing is, what that thing is that makes up a field or what the field represents. Okay, and so we look up this fellow. He says the weird nature of quantum mechanics. Weird nature. Why does he use the word weird? Well, that's because that's the word that all the authorities that he listens to use the word weird. They say, quantum is weird. Quantum is irrational. Only idiots believe in quantum. Let's say it like it is. Don't say weird. Say irrational. Say idiotic. Don't say weird. Well, why do you use the word weird? Like, see, it's strange. No, it's not strange, it's idiotic. The explanation is idiotic, it's irrational. Don't say weird when you mean irrational and idiotic. Don't confuse those terms, okay? This is where the problem is. People say, well, it's weird. My God. Here are some videos which help us explain some of the issues. Oh, okay. I want to explain just one issue. Let's find out. These people don't make up hypotheses, meaning me, right? That are inconsistent with observations and experimentation. Okay, tell me what observation tells us that there's something called a wave packet. The hypothesis known as the wave packet. How about a particle, which ain't a particle, because the particle is not the classical corpuscle. How about, how can a particle be at two places at once? Is that what they proved with experiments? How did they prove that a particle can be at two places at once? Or please draw an H atom. I mean, you're saying it's consistent with experiment? Okay, just draw an H atom. What are you going to draw? A little bead rolling around a little ball, a bowling ball in the center? So don't tell me that hypothesis must be consistent with observation and experimentation. Not one of quantum mechanics observation and experiments matches the nonsense that quantum proposes and has been proposing for over 100 years now. So no, it's not true. And he mentions some people there, some references. And yeah, I got to laugh at all these people. One is Sabine Hassenfelder. I talked about her a couple of weeks ago. I mean, this lady doesn't have the slightest clue about anything. I mean, she's not a physicist. She's a mathematician. She does a lot of equations and has no idea whatsoever about anything related to physics. And here's proof, evidence. Okay, let's show some evidence, proof. Let's convince people, which is what the mathematicians do. Okay, here it is. Let's convince people. What does this lady talk about? Well, she says she's got a site on YouTube, says science without the gobbledygook. Okay, let's find out if that's true. And she has a video, one of them, because this is her main topic, the one she works on with her group here in Germany. In fact, she works a couple miles here north of where I live. And she says, are dark energy and dark matter scientific? And I highlighted that area. It says, dark energy and dark matter are entirely normal and perfectly scientific hypotheses. And there you see what dark energy is. It's that, all that smoke that's pushing all the galaxies apart. So this is what she studies. This is what her group specifically does every day. This is her bread and butter. Okay? So she believes in dark energy. And what is dark energy? Well, dark energy is there was an initial explosion called the Big Bang, and everything's moving farther and farther away from each other, according to some of these so-called mathematical physicists. And so they say everything's moving out, and that's because of the Big Bang. And then the question is, why doesn't gravity pull everything inwards again? Well, they say it's all this dark energy that's pushing everything out. Okay, so what is dark energy? I mean, who was it? Feynman says no one has the slightest clue what energy is, but now they invented dark energy. Now they found out it's dark. So what is this dark energy? What physical object is it if it's pushing all galaxies away? I mean, if it's pushing the Earth farther and farther away from whatever, then, and the whole solar system for that matter, right? We're talking about something that's coming up against the skin of the Earth, the skin of the Sun, the skin of Jupiter. What is that something that's pushing us or pushing all these galaxies apart and all this stuff? You got to identify the object, the thing that's pushing us apart. Or is it a spirit? Is it, should we call it spirit, dark spirit maybe? Is that a better word, or is that too religious sounding? Because that's what they're saying. They're saying it's magical. It's something that's not there. It's some kind of energy, whatever that is, that's pushing us all apart. And that's what this lady studies. What can she know about physics? What can this lady know about physics? Physics is about explaining mechanism. These people cannot explain who their fathers were. Okay, here's the other fellow. His name is Jim Baggett. And another nonsense that you'll read in his site. What does this guy say? He says, well, he says many things, but I focused on this one because it's so interesting. He says, but how does the electron go from being almost everywhere to being here? You can see the word here, that's where the electron is. This is where it came out of, and what they can't figure out is what's in between. The dragon, he said the great smoky dragon. Yeah, that's the one we need to identify. What is that physical object? What mediates transactions? Gravity, light, magnetism. We need to identify the smoky dragons. Has Mr. Baggett done that? Does he know what physical object is there? No, he just ponders it. There's got to be an object there, but we don't know what it is. And that's the end of the story, and then continue doing math and explaining everything with nonsense, with irrationality. Now you got to identify the object, then it's completely easy to understand. Then it's rational. If you don't identify the invisible objects, that which has shape, right? Not that which we can touch or see, then yeah, you're going to be running around in circles like these people have been doing for the last 400 years, at least. Okay, and here's the Fermi Lab, the last group that this fellow identified, site. And what does Fermi Lab talk about? Well, they talk about several things, but I like this one because they talk about the multiverse. They say that every time you take a step, you branch off into different universes. This is what Fermi Lab tells the people out there. This is one of the authorities that this individual listens to and pays attention, called science. He thinks this is science. It says the wave function predicts what can happen when you collapse the wave function. Great. You literally create several universes in which each one of the possible outcomes occurs. This is what they're teaching the new generation. They call this science, and this guy swallows it like candy. Unbelievable. He thinks, yeah, it's a multiverse. You know, we branch off into all these universes. They actually believe this stuff. They have no problem. And then they laugh at some of the other people and say, oh, he believes in God. He believes in spirit. What do you believe in? You're believing that you branch off into a million universes every time you take a step? Unbelievable. Half of the world laughs at the other half. Okay, and a final comment here by someone. Fellow says, I can get this up here. Bill, rigid means single piece. That's me saying that. He says, no, rigid means unable to bend or be forced out of shape, not flexible. Oh man, got so much to say about that. Let's see if I can synthesize. Yes and no. We got both here. When we talk about rigidity in our macro world, well, we know that nothing is rigid. Not even a steel beam is rigid, because you can send vibration through it. You can bang it, and your sound will move through it. So something's vibrating in there. Okay, so a steel beam, as solid as it is, or a concrete wall, as solid as it seems, everything is non-rigid, because everything is made out of parts known as atoms. And so nothing is rigid. Okay. In our macro world, let's get the context right here. In our macro world, it would have to be made of a single piece. Like if all the atoms somehow were fused together into a single, like this guy said earlier, there are spaces between, the dots, and he's saying, no, there ain't, everything's covered with dots. Let's assume all the dots are fused and you have a plate made of a single piece, somehow. Imagine that, like flowed and it made a single piece. Well, if it's like that, only then can you talk about rigidity in our macro world. In our macro world. Okay? Now, under the rope model, we have a strange situation because, the thread is something that's unique. And we don't have any comparable thing in our macro world comparable to the thread. The thread is made of a single piece, but it is flexible. And everybody goes, oh, that's where everybody goes nuts. What do you mean? It's made of a single piece and it's flexible? Yeah. And in our macro world, we have no analogy of that, because everything is made of pieces, of atoms, and therefore we have no rigidity, and the only way we can imagine rigidity if it's made out of a single piece. So again, yes and no. You got to look at the context in order to answer that question, okay, correctly. So you don't have to confuse the definition you found in the dictionary with what we have in under the rope model. We have a new situation here where we're proposing that we have a thread made of a single piece which has the property of flexibility. Okay, it's malleable. And all you got to do is accept that in order to understand the theory. Doesn't mean you have to believe in it. It's just you concede the assumption in order to understand the theory. That's all there is. Whether you believe that that's how the universe is in reality, well, that's known as religion. We all have our religions. I have mine, you have yours. You believe in what you have to, I'll believe in what I have to believe. And with that, I'll see you on Sunday. Bye-bye.